So let's take a look at this function here that we've got graphed to sort of just get an idea for, well, this thing that we're going to call value testing, which is to say when you look at this particular function as its values change, let's ask the question, when do the function values go from positive to negative? When does the function go from above the axis to below the axis? Well, I claim there's two ways that that could occur. Because when you look here, the function is above and then it dips down below. One way for the function to go from above the axis to below the axis is to cross the horizontal axis. One way for a function value to go from positive to negative is to encounter a function value of 0. And that occurs here at x equals -2, at x equals 7, at x equals 14, and at x equals 16. At each of those points, the function goes from one side of the axis to the other by crossing the axis in between. So at each of those points, you encounter a function value of 0, that function value of 0 being the thing that takes you from the positives to the negatives, from the negatives to the positives. But there is sort of a pathological case that also occurs, which we see at x equals 10. It may not happen quite as frequently, but it does happen, which is to say you could have an asymptote. And if you notice at x equals 10, the function value goes from positively valued to negatively valued on the other side. So another way that a function could change value from positive to negative would be if it changed from positive to negative at an asymptote. But the long story short is that whenever you look at all of the possible ways that a function could go from above the axis to below the axis, there are two. And whenever we value test a function, we're going to look at these two possibilities precisely. So we're going to say, okay, if we're going to value test a function, the first thing we want to do is we want to find where the function value is 0, where the function is at the axis, and then where the function value doesn't exist, where we might have some kind of asymptote. So if you look at this function here, there's going to be a small handful of values, but in particular, x equals -2, x equals 7, x equals 10, x equals 14, x equals 16. These are all of the positions where the function could change sign. Then what we're going to do is we're going to test elsewhere to see if the function values are positive or negative. So if we know that we've got a 0 value at -2, we could look to the left of -2, or between -2 and 7, or between 7 and 10, between 10 and 14, between 14 and 16, from 16 on, to see what the function values are. Because actually, as I've drawn this function, every time it encounters one of these points, the function is changing value. But if you think about it, that wouldn't necessarily have to be the case. What if I just erase this piece above here, and then draw the function doing something like so? Here the function is still striking the axis, but it's actually not changing sign. But the long story short is, if we test if we test between these points where the function value is 0 and the function value doesn't exist, we can have an idea for whether the function is above the axis or below the axis, which at least tells you something about the function. If this function was describing your bank account, it would tell you whether you had a positive or a negative balance. If you were talking about profit, it would be whether you would be making a profit or losing money. A variety of things. Heck, you could be talking about like the position of an object, whether it was to the right or left of some point, the velocity of an object, whether it was moving right or moving left, you name it. So, long story short, let's go through the process of value testing. Again, first thing we do, find where the function equals 0, find where the function doesn't exist. Second, test everywhere else to see if the function's positive or negative. So let's start with a very basic example. This is a line, in fact a positively sloped line, and hell, you know what this is going to look like in effect. Whenever you think about this function is going to be a positively sloped line with a slope of 3. So you can sort of imagine what this looks like. But without knowing what the function looks like, let's just pretend for a moment that we don't know that this is a line. Let's go through the act of value testing. So what's the first thing we want to do? We want to find where our function has a value of 0, or where our function has a value that doesn't exist. Now, first off, to know where something wouldn't exist, which this doesn't happen quite as often, but these are the asymptotic cases, where the function value wouldn't exist is where you have a denominator equal to 0. It doesn't happen all that often, frankly, but we need to be conscious of it in the event that it ever would. But in this case, note, this function 3x minus 9 has no denominator, so we're not going to worry about the does not exist case. If the function had a denominator, we'd have to worry about where the denominator was 0, but that is not the case here. So what do we need to do? We need to find out where our function value equals 0. We've already observed that the function does not exist, is not going to come into play here since we have no denominator. So let's instead find it where the function value is 0. So what we're going to do is we are literally just going to set our function equal to 0. This is going to find us the x coordinates where our function has a value of 0. And if you look at this, you could subtract 9 from both sides and divide by 3 and get x equals 3. Now this is not our answer, this is just telling us where our function has a value of 0. So if you imagine your function along the x-axis, the value x equals 3 is where the function is crossing the x-axis. And now to value test, what do we need to do? Since we've identified where the function might possibly be crossing an axis, where the function might possibly be changing sign from positive to negative, all we simply have to do here is test. So let's do that. Let's test a point now to the left. Any value to the left of 3 is going to work. So let's just test 2. 3 times 2 minus 9, 6 minus 9. Well, that's minus 3, but hell, I don't even care specifically that the value is minus 3. All I care about is that the function value is negative. Because that's going to tell me now, because we know that the function has a value of 0, 3, and no other values of 0 along to the left. Well, if the function is below the axis here, there's no way for it to cross to go above, because if the function were to cross to go from negatives to positives, it would have to cross to 0, so the only place that could occur would be at x equals 3. So by knowing that our function has a negative value to the left of 3 at 2, it tells you that the function has a negative value everywhere to the left of 3, which is actually kind of a powerful thing when you think about it. Now, go to the right of 3. We want to know whether the function has a positive or negative value here, because again, it's possible that the function would just touch the axis and again go below. Let's test though. Let's pick a value to the right of 3. We know the function has a value of 0 at 3. Let's go to the right of 3 to see what the function's value is. I could pick any number to the right of 3. You could pick 5, 6, 7. Hell, you could pick 3.1 if you wanted to. I'm just picking the smallest number to the right of 3 because that would be easiest to work with. And that would be what? 3 times 4 minus 9? And again, while you can see 12 minus 9 is 3, we really don't care that it is 3, we just care that it is positive. Because this is in effect telling you that to the left of 3, the function lives below the axis, and to the right of 3, the function lives above the axis. And that is enough to give us significant and substantial information about the nature of the function. So we can say, by virtue of our value test, that our function values are negative from negative infinity to 3, and our function values are positive on the interval from 3 to infinity. Which, now, let's take a moment back to reflect upon this, because, look, we can see that this is the case from going through our value test, but whenever we then verify with the nature of what we know our function would look like, this is actually consistent, right? Because when you imagine a line striking the x-axis, when you imagine that line being positively sloped, you know to the left of where it would strike the x-axis, it's going to be negative in value, and to the right, we're going to be above the axis and positive in value, and that is precisely what our information tells us. But the long story short is this. Take any function. Look at where that function has a value of 0. Look at where that function has a value that might not exist should it have a denominator. And if you look everywhere else, you can determine if the function values are positive or negative, because the only way for a function to go from positive to negative is to cross a value of 0 or to have an asymptote. So if you find where the function has a value of 0 or doesn't exist and look everywhere else, you can tell everywhere that that function is positive or negative.